Hi, this is Colin Harrison. This is question 18 from the Briggs textbook of section 10.3. So this is question 18, and it gives us this function, which I've used change of base to write this way so that it's easier to derive. And the first question, part A, asks us to find the first four non-zero terms of the Maclaurin series. So the first step of this is going to be deriving. So the first derivative is going to be 1 over ln 3 times 1 over x plus 1 times 1 because of the chain rule. The second derivative will be 1 over ln 3 times 1 over x plus 1 squared times negative 1 from this exponent. The third derivative will be 1 over ln 3 times 1 over x plus 1, negative from here, it's just negative, times 1 over x plus 1 cubed times negative 2. So this will be a positive term overall. And the fourth derivative will be 2 over ln 3 times 1 over x plus 1 to the fourth times negative 3. So this will be a negative 6 overall. So now we're going to want to evaluate these as 0. So f of 0 just gives us ln of 1, which is 0. So this first term is 0. So we're going to leave this out later because it asks for the first four non-zero terms. F prime of 0 is going to be 1 over ln 3 times 1 times 1. This term is actually always going to evaluate to 1, we can see. So this is 1 over ln 3. F double prime of 0 will give us 1 over ln 3 times 1 times negative 1. So that's just going to be negative 1 over ln 3. And right now I'm starting to suspect that this is going to be an alternating series. F triple prime of 0 is going to give us 2 over ln 3 times 1, so that's a positive 2 over ln 3. And the fourth derivative of x is going to give us negative 6 over ln 3. Negative 6 over ln 3. Okay, so part B asks us to write this as in series form. So I'm going to first write out the terms for this. Which are we rule out the 0 term, and then the first term is going to be f prime of 0, so that's just 1 over ln 3, as I found before, over 0 factorial times x to the 0, which is just equivalent to 1 over ln 3. And then the next term is a minus 1 over ln 3 over 1 factorial times x to the first, plus 2 over ln 3 over 2 factorial times x squared minus 6 over ln 3 over 3 factorial x cubed. And you'll see here, or you'll notice that these values here all get canceled out by the factorials beneath them, as 6 is equal to 3 times 2 times 1, that's 6 as well. 2 over 2, 1 over 1, 1 over 1, they all go to 1. So we can just get rid of these and write this instead as 1 over ln 3 minus x over ln 3 plus x squared over ln 3 minus x cubed over ln 3. And then to write this as, in series form, we'll go sigma k equals 0 to infinity. This is alternating series, so negative 1 to the k. If we start that at 0, we'll get positive, then negative, positive, then negative. That's good, that's what we want. And then we see it's x to the k over ln 3. So fairly simple. And then the last part, C, asks us to find the interval of convergence for this series. So we are going to use the root test because of this a to the k. So to test for absolute convergence, for the root test, we'll say that r equals the limit as k approaches infinity of the kth root, the absolute value of x to the k over ln 3, which is just equal to the limit as k approaches infinity of the absolute value of x over the kth root of ln 3. We can pull this absolute value of x out, and then we'll see as k goes to infinity that this is going to approach 0, which means 1 over a positive 0 takes us to positive infinity. So we'll have this x times infinity. And so the only way for r to be less than 1, meaning that it converges, that's how the root test works, the absolute value of x is going to have to be equal to 0. So x is going to have to be equal to 0 in order to make this infinity, or the limit, this infinite term, go to 0, or anything below 1 for that matter. So the interval convergence for this series is actually just x equals 0.